Hey guys, Ryan from Spyker Workshop, and in this video I'm going to be showing how to wire up the Spyker Cat electronics kit, which is what will drive the motors and the tracks for the Spyker Cat. And also, this is just for the kit electronics, because on my website you can buy the electronics already soldered and ready to go from me. But this way it will save you a little money if you want to put it together yourself. This is some of the stuff that you'll need. A heat gun for the heat shrink. You can also use just a lighter. Some kind of soldering iron. I would recommend getting some kind of actual soldering station. This particular unit is from Hobby King, and this whole station was only like $20, so you can get these nice ones for really cheap. I would avoid using the just handheld stick ones like this. They just don't put out enough heat for what we'll be needing. And then also we'll need some kind of wire strippers and wire cutters and solder, of course. So this is the stuff that the electronics kit will come with for just the cat. These printed parts are included with the printed kits already, so you should have those already. Also, the motors are included in these kits, but I already have them installed in the cat, so I didn't want to take them back out to make this. But they are included. And then just to show you kind of an overview, it looks like a mess, but don't freak out. We don't need to do all this. This was kind of my rough draft. I haven't made a final nice wiring diagram yet. But it's basically, we'll be making a wire harness for the battery pack, and there's an optional additional thing you can buy which will give you 2 wire harness packages. And on my website you can select what battery connector you want, because I can put pretty much whatever you guys need on these things, or I mean ship them to you. And then we'll be doing the power switch, which is that red thing there. And then it's kind of a big mess to connect everything together. So what I've come up with is this circuit board, which I'm still waiting on in the mail, but it will look just like this. And what it will do is you'll solder in Dean's plugs directly into this board and fuses, so you can protect the components. But this basically eliminates the giant mess of wires that just get heat shrink tube together, basically. But this is like an optional upgrade. If you buy the electronics for me already ready to install, it will include this. It will include the version that's already fully ready to run. But otherwise, if you don't want to get that from me, the other option is just bundling all the wires together like this and soldering in the power wires. I'll go over all that once we get farther in the video. But this board has a cool function of taking in 2 of the wire harnesses I was talking about, so you can run 2 battery packs to give you more runtime. And then there's a port for the switch. They're both positive here, and we'll be soldering on the switch basically on a wire here to turn everything on and off. And then it has individual things that will go out to the speed controllers. And then these other functions you'll use if you buy the other hardware kits for me, like for the snowblower, because the snowblower stuff's all sold separately, just because some people, might just want the cat. And then there's also a 5-volt breakout side, so you can distribute the power like for the lights and anything else you guys might want to add in the future. And then this port here will be for the voltmeter, which is back there. So that's kind of the broad overview of what we'll be doing, but I'm going to go in depth and show you exactly how to put this wiring kit together. So the first thing we will do is get the wires soldered onto the speed controllers. And one thing to quick mention is I'm not sure which connectors the kit will include yet. It will either be Dean's connectors or, yeah, XT60 connectors. Either of these plugs will fit into my board, but I just haven't decided which one I'm going to use yet. Most likely we'll end up going with these, but I'll probably be using the Dean's for the video, just because I don't have enough of these here right now. So I unpacked the speed controllers here. Careful not to like build up any static charge on yourself, to static charge the board. As long as you're not rubbing your feet around while you're doing this, you should be just fine. But these are the drivers that I'm using from Pololu, which is a really great website. They make these boards there. And they come with some connector pieces, which we will not use. They don't handle enough current for this, so just don't use those. And then we will be using just some of these connectors to get the RC port soldered in. So here I have the power wires. You'll get a long strip of power wire in your kit, and you'll have to cut it to size here. So I have 2 sections at 6 inches, and then 2 sections at 4 inches. And I'll show you just the rough outline of what we'll be doing here. It will be the same for both boards, so I'll just show you one here. We'll split that up in half. So if we take a look at the pinout of these boards, which I got from the Polo website, the power wire in from the battery will be ground and V in. And if you bought this board from me, we're going to basically be wiring the positive side of the ESC1 to V in, and then the negative side to ground. If you didn't buy this from me, it's still the same procedure. You'll just be making a big clump of wires, and you're kind of on your own for that, honestly. You'll just have to put a crap load of solder on a bunch of wires, which is the reason why I made these, to save you from doing that. So I'm going to use the longer wire, the 6-inch one. I'll use that one for the batteries, which are on the ends here. And then for the middle one, this one will be running the motor. And since we're going to be putting Dean's or some kind of connector on the motor, because they already have pretty long wires, so we'll put a connector on the ends as well. We'll do that in a little bit here in the video, but for now let's just get these wires connected. But these I'm going to split at the ends, or actually I might as well just take them all the way off, it'd be easier. And then you might have a different wire cutter, but I use this thing, which is really sweet. But I'll clip all the ends. So then once you have all the wires ready to go, they call it tinning the leads or tinning the tip of the wire. I got the soldering iron all warmed up, and you basically just want to slowly feed in some solder until you get the wire up to temperature. I like doing it from the ends because then it will heat up all the strands down the length. And then I'll do that same process to all the ends. I'll show you one more here. And everyone has their own technique for soldering. I've just found that this works for me. So I'll do all those. One thing is also, don't rush through this. You can't really do it quickly because you need to allow the wire time to heat up and absorb the heat, because the heat is what makes it actually, solder on there. And then also be careful so a big glob doesn't start forming on there. I always tap it in the holder mount for it. And also make sure the wire doesn't have loose wire sticking out like that. Just kind of twist the wire and twist them back into the wire like that. before you put solder on it. And also, don't go crazy globbing the solder in there. I kind of feed in some and then just wait a few seconds while it like soaks in. And then when I'm done adding solder, I leave the hot iron on there just for a few more seconds. Just lets the solder get all the way inside all the strands. So now that I have all of the wires ready to go, I'm going to take the board and put it in the vise very loosely. I kind of had mine at an angle so I didn't damage the USB port. Make sure it's not there. And then here's the pinout one more time. Let's see, I'll try and just keep it there while we do this. So before we put the wires on here, we need to put solder on the pads so it has something to actually solder to. So they used 3 terminals to spread out the current and heat and stuff. So you kind of blend them all in one big clump. And when you're working on a board like this, try not to hold the soldering iron on there for too long. Kind of do it in like short bursts. And this one's so close to all these terminals, so try not to overheat any of these, because if one of these moves, you're kind of screwed, honestly. Just be careful when you're doing this, for sure. I actually switched hands because it's a little easier like this. But you want to get all those little pads. And then once you have at least something on there, then I'll go ahead and, using the longer wires, so I'll do V in, which is on the end here, and I'm putting the soldering iron on top of the wire until you see the pads like start to liquefy there, and then try and hold it in place until it solidifies, and then that's a pretty good joint like that. And then it's easy to work your way down the row so you don't have to solder over the top of something else. And since the motor wire's on the inside, I'm going to switch over to the short ones. I'll use ground for B, but this order doesn't really matter because you can always switch the direction of the motor from the controller, but just don't mix up the main voltage in or ground. And then I'll use the short red one for output A. You can see some of them go really fast, like that's all the heat it needed to liquefy there. And then finally the long black one for ground. So it should look like this now. So we have the battery wires on the outside, longer, and then the motor wires on the inside, shorter. That way you can tell what you're plugging into easily, if you always remember that. That's the way I always do it. And then you'll want to take the board out and examine where you did your soldering. And depending on how well you see, you might need to take out like a magnifying glass or something. Just make sure you didn't bridge any of the connections between themselves. And then also there should be no connections being bridged on the bottom, but it's fine if the little dot's connected to the big one, because it's, like I was saying earlier, they all share the same continuity. So the next thing we need to do is, your kit will come with these. I forgot to show them in the pictures, but you will come with 2 servo extensions, and these we're going to be using to get the servo signals to these boards. So I'm going to go ahead and clip off about 1 inch or so of these. So they're just a couple inches long here, like this. So then we need to remove the red wire from the servo leads because we will not be running power to or from this board in 5 volts. So I'll clip the end down the middle here so I can get at it to pull it apart. And then I'll pull the red all the way down. And then to actually remove the red wire from the plug, it's a little challenging to do. I would recommend using a dull X-Acto knife so you don't cut yourself, but I'm not sure if you can even see that on the camera. Let me focus it here. There's like a terminal that you gotta lift up, that plastic piece. When you lift that up, you should be able to pull out the red wire. And then I'll do that to the other plug. So here I have the red wire removed, and I also stripped off just a little bit of insulation. So I'm going to go ahead and just put some solder on the very tips of these here, which is challenging to do to loose wire sometimes. And then after I have those tips soldered, I'm going to come back with a clipper and clip them off so there's very little wire exposed. Just like that much or so. And now we can solder this onto the board. So if we take a look at the pinout again here, we'll be using the RC line, which is running down this path here. So it should be the RC signal on the other end of the board. You can see I put solder on those 3 pads there. So I already got it started. So then to actually connect it, and this is pretty tricky because you want the wire to not, touch any other pads. And then for the ground wire is on the outside here. So it should look like this when you're all done. And make sure to look really close to make sure you didn't bridge anything before you ever apply power to it. But now we have a speed controller. So I'll do exactly what I did to this one to the other controller. So now I have both up to this point, so we can continue on. So next we're going to put the plugs on the wires, and I'd like to quick talk about them for a second. These are Dean's connectors. This plug is normally on the battery end, and same with this one. And then this side is normally on the speed controller end. Here you can see like a stock battery that has this plug on it. It's the same style as the one here. And you want to note, like when you're doing power systems like this, that each plug should be used in certain situations. Like for example, this battery has live voltage to it right now, so you want to put a plug on it that can't be shorted easily. Like if you look at this side, if something fell in there, it could touch both terminals at the same time and short it. It's kind of the same exact thing as this. This is completely exposed, so you don't want live power to be on this plug. You'd put it on a plug like this, so nothing can short on it. So the battery input on the speed controllers, the input won't be live ever, so you can put the exposed plugs on that. And if we take a look at the pinout one more time, which is this way here, the outer terminal is the voltage in, so that's what I'm using here. And for Dean's plugs, they all should say it, but this bottom wider terminal here, this is positive, so that will go on that end. And then these ones have it listed right on the side there, which is positive. So yeah, it would be this one also that would run here. And then the plug that we'll be putting for the motor, the same kind of principle applies. So this wire could potentially have live voltage to it, because when the motor driver is turning on and off, these wires will become live. So these wires should house one of these style plugs, the same that's on the battery pack. So basically it will look like this on here. If that makes sense. I hope that makes sense. It's kind of complicated, but basically never have exposed terminals with, live voltage. Because like here you can't plug in a voltage to the motor wire. You could, but I don't really know what would happen. But these wires should never have a voltage coming back out them, is basically what I'm saying. Hopefully that makes sense. But anyways, before we put plugs on at all, your kit should come with some heat shrink tubing. So I'm going to cut up little sections of the heat shrink and preload the heat shrink on all these wires. So I got the heat shrink tubing loaded on here. And one thing to note is if your wires are extremely long, like this one's kind of long, I would clip them down just so they're not like super long, because you don't really need to use more shrink wrap tube than you need to. So I'll start with the power in wires, which will be the male, and I'll be using Dean's connectors for this. So what I normally do is actually plug them together, and just remember the shorter side is the male, and then I put them in a clamp to kind of hold them for me. And then this is the way I do Dean's connectors. I'll hold the soldering iron upside down and feed it on the inside like that, and then come back up on the top of the other like that. And then the longer side, like the wider side, is positive. It should also say on the side. And then I just kind of hold the soldering iron up underneath for a couple seconds, and it creates a really good bond like that. Just make sure it's not touching the other terminal. You'll have to inspect it, after you take it out of the vise. See if my camera focuses. There we go. So you can see it looks like one loose strand, actually. So I will take my knife and kind of move it out of the way, and then I'll actually cut it off. There we go. And you'll also want to check all the way around the plug. Like, see how that's sharp right here? I don't know if the camera's focusing. That sharp end will poke a hole in the heat shrink tube. So you want to make sure to cut any of those sharp ends off also. And then to do the, to do the other side, we can actually take that same plug and just flip it upside down in the vise like that. And the reason I connected them before soldering is it spreads the heat out more, so you don't melt the case of the connector. Because you can do that where the terminal actually becomes loose and wobbly in there. So I'll do the same thing upside down with solder on like that. Sorry if my camera keeps going in and out of focus. I'm not sure why it keeps doing that. And then I have the positive go like that. And the negative. And then now I can take them apart, do the same inspection. See, there's another one that's a little too high, so just clip it off. And then you can see, so we have the power coming out from the speed controller to the motor is this style plug, and then the power coming in is this one. If I sent you these connectors instead, it would be this one on this plug and this one on the one that's going out to the motor. So then I'll do the same thing to the other side. And then to actually get the heat shrink tubing in place, move them all down. Make sure you've clipped up any sharp ends of your soldering. And then kind of hold them upside down. And then you can either use a lighter or a heat gun. So I'm going to use a heat gun. And I always keep spinning them so it evens out the heat. And then both of the speed controllers are ready to be installed, but there's still much more to do. So one other thing that we have to do quick is these motor drivers need to be programmed to be set up for the Spyker Cat. From the Pololu website, or check the links down below, I'll link this. It's a program that you install on the computer. Simple motor control center. And the boards that we just soldered up, I will take and plug them into a micro USB. And once you plug it in, you'll see all these lights blink, and then eventually the program will detect it. Once all these buttons show up, it means, or as you can see right here, connected to, and these are the 24 by 12 version. And you can see there's all sorts of crazy settings in here. These controllers can actually limit the current out to the motors, which is set here, which is pretty awesome. But I have a profile already created that you can download on my website, or the links in this video down below. And when you download that, just go to Open Settings, and it's the 24V12, and then Open. And then down here, apply settings. So now everything is set for how the cat is supposed to be used. You can see it's in RC mode, and like everything's already set for you. And then after you hit the apply settings, you can unplug the motor driver, and then do the same thing to the second one. And then if it doesn't connect, it probably is, just use this drop down box and switch. And then we'll have to reopen the same file and then apply again. And now both drivers are ready to go. So just to show you, everything that we just did is only this part here of the wiring diagram. We put in the two speed controllers for the motors. So the motors will be done just how we did the speed controllers, just putting some Dean's plugs on the end, and put the male version on it, on both of them. And then once you have that done, the next thing is, depending on whether or not you purchased this board from me, we'll have to tie in the power from the motor controllers up into the batteries. And my board makes that easy. So if you got this from me, which like I said before, I'm waiting on these in the mail, but you will be putting on the Dean's connectors like this here. So these holes are for the connectors, you can see. So this first one here is ESC1 and ESC2. That's where these speed controllers will go. So you'll basically do, it's very similar to what we've been doing, but you'll solder in the Dean's connectors, and then also there's fuse holders and fuses, just like these here, and those you'll all solder in. It's pretty easy to see. Everything's all labeled on the board and everything. But this saves you the work of having to cut and, you know, tie all these wires in to a pile. It's well worth it to get this board. So that's the next thing I will do, but since I don't have it here, I'm gonna skip this for now. So then the next thing is the power switch, which this will come with the electronics kit. And we'll be taking off these nuts, or these screws, and just soldering some wires directly into those terminals. So for the power switch, I'm going to use a 12-inch long piece of wire. Depending on if you're using this or not, I'll be soldering one end of it directly into the board. I'm not going to use a plug here, I'm just going to go straight into the board. And then on the other end, I'm going to take the screws out of here, and then this like extra little plastic lip, I'm going to cut that off completely so it's flush like that. And then I'm going to take a male connector, and I'm going to solder it like right in place like this over those two terminals. So to solder this plug on the switch, this is the way that I've come up with doing it. Flip it upside down and start putting some solder on one of the pads. And by the way, you need a good soldering iron to do this, because there's a lot of metal to heat up here. So while that side is down, then I can come in and put a whole bunch of solder on the other side. And then when that side hardens, I'm going to go back to the other side and add some more, now that it's like stabilized and locked in place. So you can actually see the glob kind of bridges up the terminal. That's when you know it's not going anywhere. Like that's solid on there. Just some electrical tape to cover up all the exposed terminals on the inside there. So the power switch should look like this now. And then I went ahead and put the plug on those 12-inch wires. So now we have a nice quick disconnect for when we need to remove the lid. So then, like I was saying before, the other end of this wire can either get soldered into the wire, or the board where the power switch terminals are, or if you're not using this board, it's basically the red wire right here going up to the power switch and then coming back down. So treat both of these as if they're red. If you're doing this method, you might want to actually make them both red, so you can't mix that up. But once it's on here, it's not going to be that easy to mix up, you know. One thing to mention also about the speed controllers, if you do not plan to use the snowblower on your Spyker cat, then you're going to need to take an extra step with these. Before you remove the red wire on one of these, you will need to have this controller supply power back to the receiver. And the way that you do that is, there is a BEC on here, which is a battery elimination circuit, and you can have it supply either 3 volts or 5 volts. And the way that you do that is you would solder in a jumper. So the kit came with some terminals and a jumper. Those would go on here, and if you jump those together, then when you plug in the receiver, this board will supply power to the receiver. If you're using my snowblower, however, with the snowblower electronics, you will want to remove both of the red wires from this, because we'll be supplying power to the receiver from a different device. Check out the snowblower videos for that. So we should have all this done now. We have both speed controllers wired and ready to go, and the power switch ready. Next thing is to get power actually going into all these things to power it. So we'll talk about batteries really quick. So here is what the Snowcat and Snowblower are meant to be run on. These 12 volt, 12 amp hour batteries. You can use any batteries you can imagine in this, but I'm only going to cover these specific ones in this video, which will give you an understanding of what other batteries you can use. But basically, we're going to multiply 3 batteries together to give us 36 volts instead of 12. And the way that we do this is by wiring them together in series. So you can see here, this is how they should be wired. The actual batteries will put plugs on, and then these plugs will be wired together to add up or multiply the power. So it's basically the positive will go to a positive on one battery, and then the negative will come out to another positive, and then negative to another positive, and the negative will go back to the machine. And then using that same concept, we can do that twice. So we have 2 whole sets of, let me get these out of the way here. So we have 2 sets of 36 volt batteries in series, and when you wire them in series, it increases the voltage, but it does not increase the runtime or the amperage. So in order to connect 2 separate packs together, which would be 6 batteries, which is what can fit in the Spyker Cat, we'll need to also wire them in parallel. So the way that happens is they will both join together here like this, and then this will make, instead of multiplying the voltage, this will add the current together. So these 2 packs of 36 volts 12 amps will be added together to make 36 volts 24 amps, and that will give you more runtime. Hopefully this all makes sense. So in theory, you could add even more of these whole assemblies in the same wire configuration, where you would add all the red wires together and add all the black wires together. So you could make, as much runtime as you could imagine. Depending on what top bodies I release in the future, I might make a module that just holds more batteries to get you up to like 48 amp hours, which would be like just an absurd amount of runtime. But the option is there for sure. So one thing that my board does, that upgrade board, is instead of having to wire this, my board has that wired internally here. So this board, you would just plug in 1 battery pack here and 1 battery pack there. Let me zoom in so you can see that. So that does the exact same thing that I just showed you. So the board would see 24 amps, just like this. Like that's all right here in the circuit board. So I did that to save you on wiring, because this is just more wires to cut and tin the tips on, and just more stuff to deal with. So this saves you on that. Okay, so the way to start wiring these harnesses then, which I'm selling each harness or I'm selling an additional harness separately, because you only need one to get running. This whole second pack is only for runtime, but you can use everything with just one set of 3 batteries if you want. So I'm only going to show you how to do one, but obviously the second's the exact same. But I recommend these to be 12 inches. With 12 inches of wire, it lets you reach the middle and rear section in the cat. And then the runs that span between 4 inches is good for these. And these can be black or red. They don't have to be red, because it's just moving the power in between them. There really is no specific color those need to be. So I'm going to go ahead and kind of finish wiring everything up, and then you can see the end product here in a second. Since I don't have these boards yet, I'm going to actually be doing the harder method, which is kind of wiring everything up in clumps, and well, I'll show you here in a second when I get it all done. So here I have my wire harness for the batteries done, and it's exactly like my picture. So we have the negative going to a plug, which then hops in between the positive to negative, and then positive to negative, and then back out to positive. And for mine, I'm using this style connector, but on my website you'll be able to either email me after you place an order, or I might have a selection box on the order screen for what connectors to use, or that you guys want. And you don't need a connector here, but I'm putting one here just for ease of use, because my other Spyker cat, the orange one, uses the same harness, so I can switch in between them. But I wanted to quick show you guys the next thing that I'm working on here is to go from the battery harness, and then I need to split that up to connect to the receivers or the speed controllers, and through the power switch also. So the way that I'm going to do that is I made a lead that will plug into the battery pack like this, and then I made 2 like Y connections, or V connections I guess, and I did that by just cutting off a lot of extra insulation and then twisting the wires together and soldering them together. And then I'm going to go ahead and cut it in half just so it's not quite so long. Do that to both here. And then I'm going to be soldering them in like this here. I'll put the switch, even though that is negative, you know, I probably should have wired that as 2 positive leads, because it's a switch. You know, it's positive coming in and then being turned on, so it's still positive coming out. So I'm going to solder these in between here like this, and then I'll put the negative one just on the negative side here like that. Hopefully that makes sense. And then at the same time that I'm soldering all those together, the voltage meter that comes with this kit has a little wire here. And what's really cool about this specific voltage meter is it actually comes with a temperature sensor. So you can put this temperature sensor on either your motors or your speed controllers or your batteries, and the display will read out the temperature, so you can, you know, monitor if anything's overheating or anything. And then there's a plug that plugs into the back of this thing. And then there are 2 wires with solder on them, and these are what need to go to the battery pack. So I will put these after the power switch like this, and I'll kind of connect them in with the same wiring, and then I'll use some heat shrink over the whole thing, and then also put on the Dean's connectors on these two leads like this, and then those Dean's connectors will be what feeds the power into the speed controllers. So we're nearly done. And also keep in mind that all of this mess will be a lot cleaner on my board once I get these in the mail, because it will basically be the batteries coming in here, and then the switch coming here, and then both of these, I won't have to split them together like that. Those will be coming into just a plug, or yeah, in fact I won't even need to do these wires at all. This will just have a plug soldered directly into the board like this, that the speed controllers will plug into, so it's just a lot easier. And then same with this, you can either put a connector on this or just solder this directly into the voltage meter input on the board. It just makes everything so much easier. So now I have the wire harness done for the cat. And sorry, this video is pretty long and probably confusing, but it's just because there's so many different options for wiring, and it also sucks because I just don't have these boards in the mail yet, but I don't want that to hold me up from actually getting this out for sale. By the time you're watching this, I might have already made a newer, more updated video, so just make sure to check out my channel. So just a quick go over it here. So I have the battery harness, which is following that diagram that we showed earlier, going through a plug where the positive goes out to the switch, and then the positive, which I should have had this wire red, comes back down and then splits up into two separate plugs, and then the negative just goes straight to the negatives on the plugs. And then I also tapped in the leads for the voltage meter. And also, if you're putting on the snowblower, probably should have mentioned this earlier in the video. Hopefully you watch ahead to see this, but you could have added like 3 more Dean's plugs coming like the exact same thing, so having like a total of 4 plugs going to each one of these wires. Because if you're running the snowblower, you're going to also need to power the snowblower speed controller as well as the step-down converter to the speed controller that raises and lowers the snowblower. So you'll need 2 additional plugs coming out of here. But for now in this video I'm just doing the driving of the cat, so this is enough for that. And then these will be plugged into here, the speed controllers that we did at the beginning of the video. And then it doesn't hurt to just double check the pinouts of these boards before you ever plug anything in. Just make sure that you have everything correct. Voltage in and ground coming, you know, from all the battery power and stuff. And then one quick thing else to note here is on one of the speed controllers I put the red wire back on. This is only necessary if you're not running my snowblower or anything else but the cat itself. You can see on the diagram here, if I flip it all over. So I put the red wire back in, so it's putting power back out to the RC receiver. And then to do that I had to solder in those 2 little terminals that come with the kit. And then there was jumpers that came with the speed controllers. So right here I'm jumping the 5 volts up to the RC power. And this BEC, which is battery elimination circuit, this can only output like 150 milliamps. So this would not be able to supply power to a servo, but this does have enough power to supply the lights, like the light kit that we put in the hull of the Snowcat. And there's also another option of not connecting the red wire and simply adding in a battery pack for the receiver. this will supply enough power for servos and stuff if you need. But if you are using my snowblower, this 12 volt ESC that we'll be using can supply 3 amps of power back to the receiver. So if you're running the snowblower, you can take power from that, which will be covered in a different video. So next we can use these printed parts to mount the speed controllers and get ready to put them in the electrical enclosure here. So the way I do that is the board will face this way, and I'll just put 3 screws through those holes there, like that. So once I have those mounted, then I will pick a slot here, and I normally start on the very last slot like this. And then the power wires kind of go up and over the edge here, so you can kind of like try and put like a bend in them, or a crease. And then the second one, if you see there's like a gap here, run the servo wire up between that gap. Actually, I might go all the way up, so it's on the top like that. And then same with these power wires, kind of bend them so they can go over that ledge. And then we'll be putting the receiver in here in a second, but I just want to show you how this works with the lid. So this lid goes on here like this, and all of the wires basically come out the bottom. So that way when the thing is in the snowcat, if it gets wet or water splashes on it or something, all of the components inside are protected. However, it is not waterproof because water can still come up from the inside, so like this can't be submerged, like you can't go driving through a pond or something with this setup. The cat itself can do that. If you wanted to go that crazy, I would like waterproof the board itself, but this will make it completely snowproof for sure. And this is on the inside of the hull too, so it's very rare for any water or snow to make it that far into the hull unless you drive into a lake, basically. So then there's actually a couple more panels. There's a slightly different panel that has 4 screw holes, and that is for the snowblower speed controller, which we'll cover in a different video. But this blank one is where the receiver can be put in here. So on my website, these are the radios that you can get from me. They come flashed with a custom firmware, the ER9X, which is what someone made online. There's tons of information about that around, but it makes the radio a lot more powerful at like mixing and different things like that. So if you watch this is channel 1, 2, 3, 4, all the way up to 8. So the driving stick here is mixing channels 1 and 2 together, which makes it like tank control steering, which is what we'll be plugging these into, because this would be channel 1 and 2. So the receiver that comes with this, it's an 8 channel. Channel 1 starts 1 plug up, actually. So I'll plug in, and the order of motors that you plug in here, you can always switch the plugs around, like if the controls aren't working as desired. Like if you go forward and the machine turns, you can either switch these plugs, or I'll show you a couple other different methods to fix that in a second here. And make sure to check out the snowblower electronics video, which will be out shortly after this video, and that will cover over all of the other electronics, but this is just to get the cat itself up and running. So then I'll use this, actually I think it's the second notch over, and I kind of routed the wires underneath there like that. And then make sure they're not sitting underneath there. And then on this, I have the antennas do the same thing on the opposite side, where they kind of curl out of the box like that. And when this lid gets placed in, these bars will hold all the trays down. But what's really nice about this is if you ever need to reprogram the speed controllers, all of them have the USB ports facing up, so you can bring the machine over to your computer and plug in a USB if you ever want to make changes. It's really easy to. And then I'll put the lid back on, but I'm not going to screw it down yet. I'll wait until I get everything working right, you know, in case I have to open it back up. But when I do screw it down, it's using the slightly longer number 2 by 3/8 pan heads in these holes here. So now that we have all the brains ready, we can actually start putting some stuff in the Snowcat. So now we're ready to put all of the stuff in the cat here. And the first thing I want to talk about is the batteries and battery location. So these are the batteries that I highly recommend using. There's many different brands, but they're all very similar. 12 volt, 12 amp hours. And they're all about 6 inches long by 4 or so, a little under 4, and a little under 4 inches tall. And I recommend SLA batteries. I know it's like the year 2019 and people are using lipos and all sorts of new crazy stuff, but SLAs are perfect for this application because you want a lot of weight in this machine. Actually, this is talking about the snowblower. If you're not running a snowblower and just running the cat by itself, then weight doesn't really matter. So I guess you could use lipos to keep it lighter, like for going off-roading. But specifically for blowing snow, these batteries are great because the added weight will give you more traction and more power to push the blower, basically. So yeah, when you order these, there'll be a drop-down box for if you want to add the battery location parts for these type of cells. And what it is 6 of these. They're just a really simple printed part, and we'll be using double-sided sticky tape to put them in the hull so you can easily change it in the future. But they're designed to fit around the bottom of these and not let the battery slide around in the hull. And the way that I lay them out here is like this. And on the plastic version, there's like a bar here, so you're only able to put the battery like, maybe I think like right here. But it's fine. Even right here is fine, like right in the middle of the plate. But this one has to be all the way back to this wall, because our electronics box, this one that we've been working on, will be going right here. And then also this one you gotta watch out because the beam up here is thicker, so it has to come out from the wall maybe like just 1/8 of an inch or something to allow it, so when the battery is actually in here that you have enough clearance right here. So I'm going to put some sticky tape. This battery thing will come with this or similar sticky tape to use underneath here. I'll just run 2 strips along the sides here, and then it's the exact same for the rear. The rear will go in just like this here, and that's if you want to use 6 batteries. The additional 3, like we talked about earlier, just adds runtime. But for now, I'm just going to be running 3 in mine until I get the snowblower attached. So here I have the panels all sticky taped down. And then I will load in all the batteries so we can place the components around them. And also, I didn't mention this yet, but the kit, you'll have enough wire left over to wire your battery connectors right to the battery like this. That way it makes it easier to charge them. Which charging is a whole separate subject, I guess. There's so many chargers out there available. I'm not even going to cover it because you know, there's so much information already available out there. But you basically just need some kind of charger to charge them with, you know, the same plugs. The way that I do it is I charge them individually on a charger, so I'll remove all the batteries when I charge. But I think there are 36-volt chargers available out there, but it's easy to remove them because most standard RC chargers for like normal LiPos and stuff also have a mode to charge SLA batteries. In the chargers it's normally called like PB for lead. But yeah, so then the next thing to do is actually get our control box ready to mount. So we have a whole bunch of wires here. These are from the lights, and then these are the motor leads that we put the Dean's connectors on. And actually, yeah, that reminds me, the lights we need to connect into our receiver, so I'm going to open this back up. And the lights were covered in the assembly video of the cat, if you missed that. So this plug here can be plugged into a receiver. You just need to make sure that you line up the polarity correctly. So that's all that we need there to plug the lights in. So I'll just put that back on for now. And then we need to plug in our motors. And depending on if your controller, when you have this thing running, if the motors don't move the right way that they should be, one other thing you can try is flipping the motor cables to the other side. But we'll go over that once we actually get it powered. And then I'll just set that there for a minute. And then the other, like the main wiring harness that we made here, I'm going to remove the power switch and remove the voltage meter. And I'm installing them in the basher body here. So I'll put these in here. The battery meter gets snapped in there. And then this has a nut that you have to feed in from the back side. So I have that installed. And I'll plug these in last, so then we can get our wire harness ready. So we have the two plugs that need to supply power to the speed controllers. So I'll plug those in. And then it's up to you where you want to put this temperature thermometer. I normally put it inside the controller, just so you can keep an eye on what the ambient temperature is inside the box. I'm going to quick screw the cover on just so it doesn't fall off on me. Okay, so I screwed that down. So I can kind of keep the wires tucked in so it can slide past the battery over here. But for this, there's really no exact way to do it, because there's just a lot of wires to work with here. So it's kind of up to you. But then that will sit in there like that. So then we have left to connect here the power switch and the voltage meter. So go ahead and connect those to the top lid. And then our battery connections, we'll first make sure that it's off, in the off position. Because if you plug in the batteries while it's on, it will spark like a big spark just because it's connecting 36 volts to something that's powered, you know. So that is all of the connections. So then I would just double check everything one more time, like just make sure you have your battery harness set up like this here, and then you should be ready to apply power to it to see if everything works. Hopefully nothing explodes, which it shouldn't. So turn your radio on first, and then turn the power on here. And those Pololu motor drivers are very advanced. They have all sorts of features, like they won't apply throttle to the motor if like you accidentally had the stick down for some reason when you turned it on. They have a lot of safety features built into them. So we can see the voltage meter is working. It's saying we have 39.4 volts, and if you hit the play arrow, it shows the temperature on that thermistor that's in there. And this voltage meter has its own instruction manual that it comes with to configure it. Okay, yeah, so it looks like to set the voltage meter, because you have to tell it what type of, or what size battery pack is plugged in, you hold the arrow and then push the arrow until that number turns to number 1, and then push the power button, and then push this until it turns to P, which is for the lead battery. Push the power again, and then here you select what voltage you want to use. And then to save that, you will hold the power button, and then just turn the unit back off, wait a couple seconds, and then turn it back on. And you can see it said P36 there for a second, so we know it's set right now. And now to try and configure the motors. So depending on what type of joystick you ordered, because I sell them in left or right throttles, this one is a left one. So use just a little bit of throttle because the thing has a lot of power to it, just to see. So I'm going to push forward on it, and you can see that the machine's actually spinning left and right. So if I push left and right, it's going forward, so it's reversed. And one thing to note, the controllers, make sure you put my settings on there through the USB ports, which I showed earlier in the video. If you didn't do that, nothing will happen right now because they won't be set into RC mode. But then also they're 40 volts maximum. So depending on what kind of power plant you're using, because sometimes when these batteries are like fully charged right off the charger, they'll actually read like 40.1 volts, and this machine won't move until the voltage drops back down to 40 volts. So one thing you might have to do is just like wait for the battery voltage to drop, because after you charge them they drop a little bit. Or you can even the lights on this unit will slowly drain them. But it's just something to keep in mind. The motors won't move unless that's below 40 volts. But once they're moving, then we have to fix the control issue. So the way to change that is hold the minus button, go into the Spyker Cat, edit, mixer, or actually sorry, it's not mixer, it is limits. And then channel 1 and 2 are our motors, so I'm going to invert one of them. And then let's see, so now forward is moving forward, but is left and right working? So left and right is still backwards, so we can try to invert the other channel, which is still wrong. So then the other option is to open this back up. I'm going to turn it off, and I'm going to unplug them and then switch them. So that means like each controller is driving a different motor now. So make sure your radio's on still. So now let's try it here. So now I have the correct controls. Backwards goes backwards, forward, and then left and right. So you kind of have to play around with the flipping the inverted section here and actually physically flipping the motor wires until it's right. It's almost like a puzzle to figure it out. So now that everything's working, just a couple more things to go over. When you're outside actually driving it around, it's hard to tell on the bench here, but you're going to want to trim the steering. This knob here will adjust the trim, and it shows up down here. To change this display also, you can go up and down. It will walk through different display options. I like the stick one where it shows what's going on there. But this trim will adjust it so, like, if you're going straight and it starts turning on you, you know, adjust that to make it keep straight. And then also you're going to want to adjust the belt tension. Like after a couple runs, while stuff works itself in, just feel on the belt to make sure that they're still tight. And also the tracks, after a couple runs, well, all the plastic kind of like works in and like, so you're going to want to adjust the idler tension just to keep them tight, you know. And then other than that, that's pretty much it to get the cat moving. It's kind of destroying my filming setup here, but one more thing to mention also is don't try lifting this thing as it is. Like for me right now, to get this from my bench to the floor, I'm going to take the batteries back out to make it lighter, and then even then I'm going to try and like just slowly tip it off the table, and because it's a lot of weight for someone to just deadlift, or if someone's around to help you, get a second person to help. Maybe probably safer to just lift it up from the frame, but it's freaking heavy. It's a heavy machine. Even with just 3 battery packs, it's like probably 80 pounds or something. It's, you know, don't try and lift that like that. So just a quick show you, here is my setup for my charger on the batteries here. I actually have 3 of them, so I can charge 3 at once, which I highly recommend doing. And then these particular chargers, they have a PB battery setting, which is for lead. And these you can charge at anywhere from 3 amps to 4 amps if you really wanted. I'd recommend staying at 3 amps to charge up the 12 volt, 12 amp hour batteries. And then make sure it's set to 12 volts or 6 cell. But doing this, you can get a full charge in about like 4 hours, or 3 to 4 hours. So it works pretty good this way here. But yeah, I would invest in 3 chargers so you can do one whole set of charging at one time. These chargers aren't very expensive. I got these on Hobby King. And they also work to charge like any type of battery, which is nice. So one more thing to quick mention here is when you have the machine powered off, I would avoid moving it, because if you see here, if I move it a little bit too much, the lights come on, which is because the motors are actually feeding in voltage back through the controllers when they get moved. So I would power it, you know, to move it. Don't move it on its own like that. Another thing too is if you want to run the snowblower but you're not putting it on yet and you just want to go drive this thing around outside like I do right now, I would recommend covering up the hole for the actuator with just a piece of tape to prevent like a ton of snow piling up inside the hull. I'm just going to use some packing tape to temporarily close it up. One other thing to show you is that I am currently sitting on the machine, and with these aluminum hull plate upgrades, it makes the sprocket a lot more rigid than the plastic version. And what that means is this thing has a lot more power to actually do a neutral turn with me sitting on it. This thing, like, that cannot do this with the plastic hull. Everything kind of flexes a little bit, just enough for the sprocket to skip. Keep in mind I weigh like 240 pounds, so I'm a heavy guy, but this can handle it, which is pretty impressive. Because a neutral turn on a tank is literally trying to slide the tracks sideways. It's like an incredible amount of force on the tracks. Like if you had someone next to me trying to push manually sideways, like you're pretty much not going to do it. So it's really cool to see that this, with the aluminum hull upgrade, can actually handle that. Like it's freaking awesome. And it sounds like the motors aren't working too hard to do that. Oops. Also, yeah, one thing is be careful when you're driving this. If you hit into your foot with this thing, it really hurts because it really is just a giant block of plastic. You know, there's absolutely no give in this machine, which is why it can handle so much weight. But yeah, just be careful while you're driving. But one thing that's nice about this whole setup is that those Pololu drivers are so, like, fine of control. Like, you can move this thing, like, very precisely and very slowly too, even. And there's like no motor whine sound, which is just awesome with these things. And that wraps up the electronics for the cat itself. I'll be doing other videos on the snowblower electronics, and the snowblower lifting mechanism will be in its own video also. So leave some comments and stuff down below, and let me know if I missed stuff, if I went too in depth. You know, just what do you guys think? Thanks for watching.